We're back again in this empty science lab, none of you guys around, and today I'm going to talk to you about naming and writing formulas for ionic compounds, okay? And it's best explained on page 81 in your textbook. If you have your textbook at home, you can reference to that, or I'll post another link that will also give you another description or some help on working with it. So what we want to do is when we're working with ionic compounds, like we learned before with combining capacity and their charges, the example I used was sodium chloride or NaCl. So here you have the name and there's the formula, okay? So what we're going to learn is how to give formulas names and how to give names formulas, all right? So when you're naming, what you do, here are the rules, okay? Number one, you always list the metal first, okay? And that's the positive ion. The reason they call it as a positive ion is because it carries a positive charge when it gives away an electron. And if you use the combining capacity charge on the table, this one's always a metal, always it carries a positive number, right? Plus, 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 non-metals, minus, 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 okay? So you're always going to list the metal first. So sodium, Na, is here. It's in the metals. Chlorine is a non-metal over here. So we list the metal first, so sodium, and chlorine is the non-metal. Okay? So we name the metal first, then the non-metal second, or positive ion, then the negative ion. The next step we do is we change the ending, we remove the ending and change to "ide." Now we remove the ending of what? Of the non-metal. Okay? So we remove the ending of the non-metal and change it to "ide." Okay? So here's a few examples. I picked different ones: chlorine, fluorine, bromine, anything that ends in "ene", I-N-E, you change to "ide." They all get changed to "ide." So fluorine would be fluoride. Okay? Nitrogen would be nitride. Sulfur would be sulfide. Okay? It wouldn't be sulfuride. You remove the ending. Okay? That's how you name a formula. So if I gave you an example, KBr, first thing we're going to do is go to our periodic table. K is a what? What is K? Potassium, and it is a metal, and Br is bromine. Okay, so we have potassium and bromine, or bromine. Okay, they form together, so if we're going to write out the thing, it's going to be potassium bromide, right? Metal, non-metal, potassium bromide. All right? So I might give you a question like, silver and iodine, or iodine and silver form what type of bond? Name it and give formula. Okay? So that is a hypothetical question that I could give you. So silver and iodine. First thing you need to do is look on your periodic table. Where is silver? Ag. Okay? It's in the transitional metals, so you know it's a metal. Iodine, 53, is a non-metal. Here's your division line. So we know iodine's a non-metal. So if we're going to name it, okay, which one do we put first? Metal, then non-metal. So it would be silver. And our second one is iodine. So iodine, we scratch that out, it would be iodide. Silver iodide, okay? Anything else that we need to do? No. Now, the second part of the question asks for you to give it the formula. Here's where it gets a little trickier. And this is where I recommend you print out or have a separate screen with the charges, because the charges are what's going to tell you how to write the formula. Okay? So the first thing you need to do is silver and iodide, find them on the periodic table and write what they are. So Ag and I. Okay, that's step one. Ag and I. Now, the next step is you need to know that they're balanced. There could be 4 silvers to 1 iodide. There could be 2 silvers and 3 iodides like we did with the aluminum oxide. You need to balance them. So silver, you need to look at your periodic table and figure out its charge. Okay? So silver carries, I have to look up on the periodic table. See, this one doesn't show the charges, so it's a little more challenging. If you are familiar with the charges and you get used to it, then it's not so bad. But silver, silver, this is a good one. It's crazy cousin. Doesn't know what the heck it's doing. Silver carries a charge of +3, +2, or +1. Okay? So it could combine with anything 1 to 1 basically. So it could join up with a lot of different things. It could join up with silver oxide, any of those, and it would only need 1. So an iodine is in row 7, and I know that these are all -1. So silver, if silver is +1, +2, or +3, and iodine is +1, this would be silver Ag1, or I, and that's it. Now, as soon as you have multiple charges like this, you need to specify it. And how you specify it is with Roman numerals. Okay? Transitional metals, crazy cousins with multiple charges. If it has multiple ones, you have to tell me which one it is. So it would be Ag. Now, if it's 1 only, you don't need to do that. Okay? But if it was +2, okay, then it would be Ag1. Sorry, I'm wrong. You only put the that in the name, okay? Not in the formula. The formula is explained off the name, okay? So the Roman numeral thing, it would be like this, okay? If it was silver, Roman numeral 2 iodide, then silver would be +2. So then, rather than AgI, it would be AgI2, because you need 2 of these to balance out with this, because we're telling you that the charge of this is +2. But because I wrote down silver iodide, it would just be AgI. Okay? I hope that didn't confuse you, but we'll do another one just to help you guys out. Okay? So, next one, I'll give you a formula. Na2O. Okay? We're going to name this one. Na is sodium, oxygen, scratch out the gin, it would be, or the egen, it would be sodium oxide. Okay? Ionic are very easy. Sodium oxide, scratch out the N, change it to I. There's nothing else that you need to know. Okay? Na2O. Na has a charge of -1 or plus 1. I always get them backwards. And oxygen is negative 2. That's why you have 2 of these, and that's 1. Because 2 times 1 is plus 2, and negative 2 plus that is equal to 0. So this is good. Okay? So let's put a couple on the board. K2S. Ag3N. Okay, let's name these. K2, potassium. S, sulfur. So potassium sulfide. AgN, silver nitride. Okay? You guys get the idea? RBF. RB, I don't even know what that is. I think it's rubium or rubidium. I gotta look it up. Rubidium. There's it. So rubidium fluoride. Etc. Okay, so that's taking formulas to names. Now let's do names to formulas. So lithium nitride. So lithium, we'll find it on our table, is Li, and nitride is there, nitrogen. So lithium, Li, N. Now we need to find the charges. So we look at your periodic table with its charges, and nitrogen, I believe, is 3. -3, and lithium is +1. So it would be Li3N, because you need 3 lithiums to balance out with the charge of that. Okay? And I'll give you one more example. Beryllium fluoride. Okay? Beryllium has a charge of what? Okay? Beryllium is in the second row, so it has a charge of +2. Fluorine is -1, so it would be BeF, and now there's 2 of these, so to get 2 and 2 you would need 2 fluorine, so BeF2. Okay, so that's the naming one. I'll give you guys some examples or some questions to try and practice them, and I will do another video on the naming of covalent compounds, which is a little more tricky, but it's not as bad. I like doing the ionic ones. They're a lot simpler and more straightforward. Okay, there's just a little less rules. All right, so stay